feature video about Mamuja and Preliminary Incident.
I'm Lawrence. I'm here. I'm a Fisheries Commission.
Nice to meet you. Mary, that's a Fisheries Commission. Nice to meet you.
My name is Hefe. I can see that you never been in here. I'm from Ghana, Fisheries Commission.
Nice to meet you.
Jacob, so Norwegian Veterinary Institute.
How do you like your stay in Egypt?
Oh, it's a nice place to be.
Okay. My name is Nirmeen. I am the Central Water Quality Lab Manager for Gabbard. I'm sure our subject today you have a good background about. We are talking about water quality management and therapeutic feeding in agriculture. The worldwide concern today is how to properly manage and preserve water resources for industry like agriculture that depends mainly on water. Water quality management is a cornerstone for the success for fish farming. To have healthy, productive, and sustainable aquatic farming system. It's not just about keeping water clean. It's about having or creating the ideal environment for aquatic life to thrive. We can improve fish production, reduce environmental impacts, and ensure sustainability for the future of agriculture. So, this is why we need to learn the story of water quality, and it's important for fish. Most agriculture systems require a good understanding of water quality and risk management for accurate treatment decisions to ensure healthy captured fish stocks with high yield and high quality. Agriculture requires a significant understanding of the factors and problems affecting production, beside the improvement of approaches and technologies in water quality management. Consequences of poor water quality. Poor water quality is due to the accumulation of toxic compounds, including ammonia, nitrite, hydrogen sulfide, together with the dissolved oxygen, the low dissolved oxygen, hypoxic conditions, harmful algal blooms, and pathogenic bacteria can greatly affect the fish health by bacterial infections, poor growth, and stress, leading them to be less tolerant to handling. Diseases in aquaculture system are closely related to the environmental health. And uncontrolled disease can rapidly go out of control and can cause mass mortality in aquaculture systems. Water quality in aquaculture system is affected by various physical, chemical, and biological factors. There are some key water quality parameters such as temperature, light, pH, dissolved oxygen, organic matter, nutrients, microorganisms, and various biological interactions. These can help us to understand, resolve any problems during production process. I tried to summarize some key points for the most important water parameters, starting with temperature. Temperature determines temperature determines metabolic rate and growth of fish. Each species has an optimal temperature range. High temperature reduces dissolved oxygen. Low temperature slows growth. pH. The ideal range for most fish is from 6.5 to 8.5. Low pH or acidic, increased solubility of toxic heavy metals, where high pH or alkaline increase the toxicity of ammonia, which is the most lethal compound for aquatic life. Dissolved oxygen. Dissolved oxygen is essential for respiration, digestion, and growth. Deficiency causes stress, can lead to mass mortality, supplied by photosynthesis and artificial aeration systems. Organic matter or nutrients and ammonium compounds resulting from wastes of feed and fish include nitrogen compounds and phosphorus from feed residues and fish wastes. High nutrients level promote harmful algal bloom. Salinity. Salinity is one of the most critical factors in agriculture. Mismatched salinity causes stress and poor survival to the osmoregulation in fish body system. Too high or too low salinity increase energy use for osmoregulation, reducing growth. Also, fish grow best at their optimal salinity range, where this energy is spent on maintaining internal balance. Outside this range, feed conversion efficiency drops. Besides, many species require specific salinity for spawning, egg development, and larval survival. Any sudden salinity changes cause stress on the fish, weaken the immune system, which make fish vulnerable to certain pathogens that can live in specific salinity range, such as Iomonas and Vibrio. Light, which affected by turbidity of water. Regulates photosynthesis of algae and aquatic plants, increasing oxygen during the daytime, effect on feeding behavior and growth of fish. Excessive light may cause algal bloom or inflammation. Alkalinity. Alkalinity buffers pH, preventing sudden swings that could stress fish. Also harness mainly calcium and magnesium, supports fish growth, shell or scale formation, and proper biofilter activity such as nitrifying liquid. Essential trace elements like zinc, iron, copper, phosphorus are vital for enzymes activity, oxygen transport, bone development, and immune system. Even for metagenesis and spawning. You know, when fish start spawning the egg in the water, unless it has the right level of phosphorus in the contents of it doesn't harden, so it will die. So this is one of the most important phosphorus solutions. However, when present in excess concentration, they become toxic, leading to damage of the nervous system, immune suppression, oxidative stress, and even mortality. Different aquaculture systems like extensive, semi-intensive, and intensive, or type system, closed, semi-open, and open, different culture species and stocking densities can generate different environmental impacts. Each ecosystem has its own carrying capacity, and working within the limits is crucial to avoid negative impacts. The transition of traditional culture practices to an intensified cultural system involves increased waste that require proper treatment to avoid pollution and harmful events on the environment. Why water management is important for maintaining water quality? Good water quality. Water quality enhancement in production systems such as RES, IATA, and aquaponics. By using efficient integration with physical, chemical, and biological factors, would boost the feed conversion ratio and improve the health of captured animals. This means low cost, high production, and this is our goal in agriculture. Techniques like aeration system, techniques like aeration system, filtration system, water exchange, monitoring tools like AI technology and IoT, in addition to recycling the nutrients using different organisms in the aquatic food chain such as bacteria, microorganisms, seaweeds, and other fish species. These all can enhance the growth, survival, protective production of the culture species. Different technologies, such as bioremediation, bioflow, and processes such as filtration, coagulation, calculation, can be embedded in closed aquaculture systems, like aquaponics and REX, or open systems like coastal water to make the waste water treatment and recycling more efficient, which in turn improve water quality and enhance aquaculture yields. Integrated heterotrophic bioflow and refined bioflow methods to control ammonia, nitrite, nitrate, soluble reactive phosphorus, and alkalinity with relevant functional microbes such as ammonia and nitrite, oxidizing bacteria, phenol-replying bacteria, phosphorus, accumulating organisms. Also, bioremediation minimizes the use of antibiotics and drugs, and thus decrease the dangerous consequences of routinely used chemotherapeutic drugs and products, safe aquatic products, and reduces safe aquatic products for human consumption, which is our main goal. About 27 to 49% of feed supply to aquaculture production homes are converted to fish products, while the rest goes to be waste that are usually discharged into the nearby water bodies, which can be serious concern in coastal and inland waters, such as rivers, lakes, reservoirs that receive aquaculture effluents, and eventually form one of the factors that negatively affect the aquaculture value chain. In these circular economic activities, aquaculture waste can generate additional products such as seaweeds, herbs, vegetables, mollusks, and other byproducts, while generating a clean water source that can be recycled and used for the fish culture. Our target plans today is to build new aquaculture projects with zero waste, and use every byproduct with the aim of new technologies to have sustainable and clean aquaculture industry. Integrated multi-trophic aquaculture system is one of the most promising and important water treatment technologies that are technically feasible, environmentally promising, and financially profitable. Can be integrated into different aquaculture systems to make aquaculture industry a sustainable sector and contributes to the circular economy. It can be used in closed systems like tanks. Next. Or even involved with wide areas reusing of organic and inorganic wastes by the organisms and plants of the environmental system. Also, integrated multi-trophic aquaculture systems can be used in coastal waters. The selection of the species from various trophic is based on their physiological and ecological functions, to ensure complete recycling of organic matter in the system with minimal waste and good water quality, which contributes to the sustainability of the aquaculture industry. Aquaculture waste can be recovered and recycled using various technologies such as bioremediation, aeration, biocoagulation, and biofiltration, applied in various production systems such as REX, IETA, and aquaponics. The rest is closed circuit high-density aquatic animal farming, where water from fish tanks is circulated to remove solid and liquid waste, and the purified water is returned to the aquaculture. It is designed to provide a more controlled aquaculture system to reduce water usage and to reduce waste, both liquid and solid waste. And thus, it's more efficient and economical compared to conventional flow-through and cage aquaculture. In fact, the relative water renewal rate can be optimized, the fish feed consumption rate is increased, and the growth rate enhanced. But it's very important to maintain effective operations of RAS systems to have strict monitoring and proper management of water brass in water quality management could be enhanced by combining the system with other functional components such as duration system. To eliminate the off-label, which increase the shelf life of the product and the quality of the product using microalgae system. The off-label compounds produced by high algal bloom, especially jasmine. Jasmine usually produced as a byproduct in tilapia produced by cages farming. Jasmine in tilapia produced in cage aquaculture. Jasmine is naturally occurring organic compound with an earthy muddy aroma. In aquaculture and drinking water, it can cause muddy or earthy off-label even at a very low concentration, parts per million. Humans are extremely sensitive to its smell and taste. This compound may reduce the quality of the meat of the fish. So we can use some technologies like depuration system to come over this problem. The ideal fish nutrition: right feed, better growth, and health. This is a golden equation for both feeding and fish farming. Balanced nutrition ensures healthy growth and strong immunity in fish. Ideal fish nutrition. Ideal fish nutrition. Right feed, better growth, and this equation is a golden equation for both feeding and fish farming. Balanced nutrition ensures healthy growth and strong immune system. For protein, consistent in feed fish, it's about 25 to 50%. This is for muscle, bone, and liver. Levels could be from 5 to 12%. This is important for energy and essential fatty acids. Carbohydrates promote energy sources and vitamins and minerals, immunity, important for immunity, bone cells, functional additives like probiotics, prebiotics, enzymes, iron for immune system and quality. At the end, as they say, an ounce of prevention is worth about using nutrition to boost the immune system by adding natural additives, which not only serve the improvement of fish health, growth and production, but also enhance the quality and taste of fish meat and improve consumer health. For example, pre- and probiotics like bacillus, lactobacillus, which improve immunity and reduce bacterial infections. Omega-3 fatty acids, which enhance immune response and reduce inflammation. Vitamin C and E and minerals like zinc, which support tissue repair and act as antioxidant and boost disease resistance. Flavonoids, extract like garlic, turmeric, or even some essential oils like clove, pepper, rosemary, also hydrolyze disease. These natural additives have antimicrobial and antioxidant. They could be added to feed of the fish in aquaculture for enhancing the quality and the benefits for consumers. Thank you for your attention. Hope you enjoy the Any questions?
Yes.
Okay.
In the area of these natural resources, the aquaculture, how do you handle the water so that this location
هنا في مصر حضرتك قلت لي حاجه الارض اللي المفروض تحصل، لكن احنا في مصر بنعمل هاندلنج للميه ازاي؟
We use all these according to the place and the type of agriculture we are using. We use aeration, bifiltration in some cases, as
according to the situations.
yes, according to the we
like you ask about the daily management. النهارده مثلا في مزرعه farm like this.
what mainly water exchange because our water quality here is good. So maybe sometimes we can use aeration or water exchange. But if the state needs more intervention, we can use other ways.
How do you remove feed that has settled to the bottom, sedimentation from waste that have gone? How do you remove it from ponds?
And ponds and closed ponds.
Yes, like we see out here.
You know, feeding have certain regulations and certain amounts. Prevention is the main key for facing this. So we don't need much intervention. Maybe sometimes water exchange or stop feeding if there is an emergency, but not more than that.
So you don't overfeed?
No.
Okay.
So here, seafood means fish waste.
Yeah.
But I'm aware that the water quality,
Yes.
the waste or the remains of the
This is artificial grass system.
Yes.
Thanks.
Yeah, I'm using this.
This is yes.
Yes. I'm using this one as an example.
Yes, yes.
So if we feed, I know that depending on the digestibility and all the other factors, some of the feeds, some can break down. They come in different particle sizes.
Yes, I know. You mean the feed waste on the bottom
Some
of
may not
the
settle, some would you have something that they call colorants. They don't dissolve.
Yes, yes, I
So
know.
how is the
Every cycle of the aquaculture, we empty the pond and starting to letting it dry.
Dry,
changing the soil, and then adding new water for the new cycle. So we don't feed it. Fix it.
Yes, so
Yes.
You ask about fibers.
لا هي بس
So this one like this, you don't exchange the water or do anything to it. Yes, this entire. No, the
normal we exchange
Yes.
at least 10% of the total amount of water every day, from now to the end of our project. Before that, we change 5%.
5%.
Yeah.
Also, all the prediction to the weather.
Yes.
Okay.
this is the concept of management. This is the concept of water management.
That is why you see it's according to the situation and it's part by part.
Yes.
So, you know, at some actual point, sometimes the quality of the incoming water is worse than the water coming from home.
Yes.
So, it is case by case. So, I'm saying that for the farms, they have
Which type?
no,
In Egypt.
in Egypt.
Yes.
I mean, you have, let's say, for water quality, and the farmers empowered have used this to be able to take water quality practices all the time, the farms.
We have yes, indeed, we have measuring threats for the water quality parameters. Maybe some parameters every day, like pH, salinity, DO. Some parameters week by week. Maybe in some emergency cases, we do more investigation.
There is a requirement for farmers to take or measure water quality parameters.
هي بتسأل إذا كان ده فرض عليهم إن هم يعملوا
يعني موضوع لازم تقيسوا ووتر كواليتي بارامترز ولا بتسيبها
but we don't force them.
And you have
Because every area, every zone in our agricultural zone in Egypt, there are gymnasiums, there are engineers, they help our farmers, and then daily I can as farmer to get Dr. Nirmeen into the farm with his advice to monitor my water. It's easy.
So how ready available are the tools for monitoring the water quality on the farms? Are they easily available?
Yes.
Do you have the tools?
Yes.
Of course, we have our labs. I'm the center water quality. That's right. Yes, we have different labs in different governments in Egypt.
But she's referring to farming equipment. Some of the farmers can use.
Yes, not the farmer, the technician managing the or the director of the farm. He's a good know information how to use some simple device.
But not the
To
farm.
take no.
The advice for monitoring water quality is not available inside each farm. Okay, but it's available in with my vehicle with my vehicle, and the farmer can get this guy to come to the farm with his device and monitor his water quality with cheap. It's available for every farmer. Yeah.
I was thinking that the farmers can take it themselves because you know when we have issues of diseases or even stress. If there is a record of your water quality parameters, it only helps to facilitate the
Of course,
solution.
this is our project in holding farms. My colleague will talk about this in the next lecture.
You know, if I can also add something, just quickly. We have also some farmers, like they are highly educated, so some of them actually, they have some case for which advice parameters. This is one. Number two, yesterday you read about the feed producers, and it's like very competitive area. Sometimes also they provide you with technical support. So they come, if you are getting your feed from me, I'm going to monitor the water quality for you. And then you have the government and the lab, or the government is supporting as well. Thank you.
I have a more general question. In your production cycle, you exchange the water, 10% of the water every day. When the water is then removed, that 10% is removed, and you have different ponds. Where does that water go? Yeah. We have. But let me finish my question. I'm not asking.
Okay.
Oh, yeah. Go ahead. Yeah. So the water, the 10% is exchanged, is moved out. You have several ponds. I'm wondering whether that water that is discharged from the ponds are collected somewhere, and then whether they are treated again before they are introduced to the system, or what happens to them?
Treatment with water.
No. You don't. So what happens to the 10% of the water?
They didn't water get out from the bone to the national and to the national and after that go to the main national.
Okay.
And after that, these main nationals come into a huge nationals to go to the team.
Oh, so you discharge the 10% of water accumulated from different sources
Let me
into
clear
the
a point.
Mediterranean.
Let me clear a point. There is an environmental treatment by sun, air, mixing water. When the water, unless there is any outbreaks of diseases or problems, there is an environmental treatment in the open canals.
Okay.
So the recycled water will go back to other farms, but it will be with no problems.
Yeah.
If there is a problem, there is another.
So what do you do in case of an outbreak in one of the ponds where water is being exchanged over time?
First, we try to control the outbreak inside this.
Yeah, but then you have exchanged water.
No,
10%.
starting first, we have to control the problem.
Okay.
Then we will discharge the water when we are comfortable that it's not consisting a problem for the neighboring farms or areas.
Okay. Let's just be a bit patient with me. Normally, when diseases are occurring, maybe they might start very slow, and then you are exchanging water 10% every day. So some of maybe those pathogens might have already entered the canal and going out. So
We have to get back to our point, the prevention is better than treatment. We have to control before having this disease.
so you don't have any disease.
No, I mean, this is a rare condition sometimes, but it's not the normal
Situation.
yes.
Yeah, I was understanding your therapeutic feeding.
Yes.
It was indicated that there are no use of antibiotics or something. So, I want to understand how you do your therapeutic feeding actually.
Let's see. Our vet, they can diagnose this situation in this pond. The fish here is having a problem in water. So we try to study the condition and get the suitable feeding with the suitable additive to deal with this. This is how we do things, not in general. Maybe in some cases for the raising the quality, but not as a cure. As a cure, each condition or each case by case. We can deal with this case by case.
Can we go to the next slide? Is it the
It's a follow-up. So you don't use as prophylactic to prevent.
This is not my
Area.
Okay, can we go to the next?
Just to go to treatment. So you're asking if we add antibiotics to the feed as a preventive? It is not common,
It's not.
but some add very few good growth promoters, and this is coming from the company selling the fish feed. Not as a regulatory, ask people to add.
No, I'm talking about
No, but
immune
we have the
stimulants. Immune stimulants.
With natural additives,
With
not
natural-
Biology, you mean, right?
Yeah.
not with drugs.
Actually, like some brand like Spritting, they have a specific feed for the food stock, for example. And I'm sure they have in some additives, just like human fiber. Some things like that, or probiotics, for example. Yeah. But,
Yes, I wanted to find out what is the purpose for the derivation that in line with the therapeutic feeding that Dr. has.
This is the regulation system. We integrate this system with our IRS to raise the quality of fish meat. I said before, there is a compound called geosmin. This is produced from high albumin. This causes a very muddy and musty flavor in fish, which make the fish to be less in price. So to raise the quality and to be able to export our production, we can use a system like depuration to come over the problem.
I'm asking this because online, if we are online treatments, maybe they don't. But then if we are online treatments,
On land,
yes, online, like here.
we can use the concept. The whole concept is to change the water. So before harvesting the pond, we can change the water and leave it for about 3 weeks before harvesting. So the surrounding area, aqua area around the fish will be changed, overcoming the problem of that.
So, yes, so if I have a land right at home,
Yes.
that's not operating, and then maybe I happen to treat the animals or something, and can I, yes, if there's a problem and then I apply this treatment to the fishes?
You mean if there is a disease or something?
Yes, yes. So for maybe for the period or to observe the withdrawal period, can I have a depuration system in place just to?
Could be used if you examine the fish, find some diseases connected to algae or bacteria or something that you can deal with in a natural way. Yes, you can.
And how long does the education take?
From 3 to 4 or maybe a week, according to the case of the fish, the intensity of the number of fish, the population,
Do you feed the fish or you don't feed it?
no.
You don't feed it?
No, maybe in very small amounts, because I don't want to go to, again, the same problem of having high alcohol or waste of nutrients in the water. Any more questions?
Yeah.
Yes.
As an institution, Lake and Fisheries Protection Authority, how do you protect the ground? Because I can imagine here you don't treat the water. So, what you bring, like when you bring the water, when you took us yesterday, the pumping machine, and imagine you just use the water as it is, you don't treat it. So how do you maintain the quality of the land? Because there are so many things going on. Yesterday you said industries, they use as drinking water. So how do you protect the land? Because I can imagine.
Regulations, environmental regulations, prevent waste.
This water come directly from the land.
Yes, I mean, how do you protect the land from human activity?
As I told you yesterday, in Egypt we plan to use the land in Egypt. Here, the industrial zone. Here, the agricultural zone. There, the agricultural zone. So, the Nile River and its canals, its branches, move the water during this whole zone. So here is the agricultural zone. There is no industry. There is no factories.
So you don't have any issues with
So there is no issue here because of the pollution of the water coming from the river. You imagine that?
But now we are not discharging the water into the Nile. James, we are not discharging the water coming from the farm.
No, that's not what I'm
But
saying.
what if you want the boundaries or
Yes, it's very
But you're talking about the industry, right?
No, I'm just curious
here, for instance, as I said, there will be sediments, things from the feces and those things.
Yes.
Do you have any form of biological control for sediment removal or using other benthic species under bottom?
We have regulation for the coding of parts.
Okay.
One of these regulations is to remove away these sediments. We don't allow them to be on the head of the home.
Okay,
So they have to be moved away into certain downs, certain downs to be treated.
Okay, I have a tank.
Yes.
A tank.
A tank.
Yes.
Earthy.
And then water.
Earthy or?
No, concrete tanks.
Yes.
And then water is very scarce.
Okay.
I don't want to change the water, but I want to do research. What do I do?
We can do that.
We can do
By
that.
using this. By using this.
By using
But they want you to rush. We can stop stand and using the but we have to also see and the feet, you have to also how you feed the fish, manage the vaccines, to prevent any risk from missing way to go. Okay.
Or to limit the amount.
Use that use.
The amount.
Okay. Okay.
But although this technique, you have to change some water every 2 weeks.
Every 2 weeks. About 10% or 20%.
No, we can speak about 5%.
5%.
There is a nice system you can use the concrete cage
Yeah.
scene in an open, in a closed pond.
Yeah.
You take a little area from part of the area
Yeah.
to make it a concrete.
Yeah.
And then you recycle the water through the cage to the pond and recycle. This promotes you to discharge these sediments to the pond and reuse the water without exchanging or needing a new amount.
This is the concept of IGAS.
Yes, precipitation tank. If you have a precipitation tank, you can move the organic waste and matters to go there, and that one you can, actually it's the same as IGRS. But then you need to focus again on the irrigation.
Yeah. No, I understand. Okay.
You can take all the benefits at once.
I want to take all the benefits.
You need to focus on the cost and the quality.